Okay, here we go, boys and girls. This is lesson 7, and this has a lot of rando information. Oh, excuse me, on here. And I will try my darndest to teach you kind of like simple strategies about how to figure this out. All right. First thing is end behavior. And I'm pretty sure we talked about this before, but I don't think we really talked about how I'm able to tell answers here real quick. How I know what end behavior is this. First and foremost, what I do is I take a look at the largest exponent on the x. And so this is x to the 4th. But more specifically, I notice that that's an even number. Okay, that's an even number. And so on the next one, I see that we have an x to the 3rd, and I know that that's an odd number. So all I really do is I look for the largest exponent that is on an x. And it's going to be even or it's going to be odd, one of the two. And if it's even, I think about the most simplistic even number that I have. The most simplistic is an x squared. And I know we talked about this last chapter or 2 chapters ago. And what an x squared looks like is this. This is what an x squared looks like. It's a parabola. But when I'm talking about end behavior, I'm asking in essence what is occurring on the right-hand side and what is occurring on the left-hand side. Is it generally going up or down? And so when I have an even, I see that it's an up, up. Okay, an even is an up, up. So if I have an even, an x, and this is the biggest, and it's an even number, all right? The end behavior is going to be up, up. If it's a negative even, okay, a negative even, then it's going to be down, down. Now, whatever happens in between is up to the picture itself, but it's either going to be up, up, or down, down. Okay, now, on this, with the same breath, let's talk about odds. What if there is an odd number on the x? Like a 1. An x to the 1 is the simplest odd number that I know. And an x to the 1 looks like this. Right? That's what an x looks like. And so what's happening is the right-hand side is up and the left-hand side is down. And that's going to occur for every single different type of odd number that there is. So if an x, the biggest x is to an odd exponent, then it's going to be down, up. If it's negative, then it's the opposite. It's up, down. So you can use your Desmos calculator to verify this. So for instance, let's just plug in something with the largest exponent being odd, for instance. Let's go x to the 3rd. Okay, x to the 3rd. Look at what's going on in the graph here. The right-hand side is up and the left-hand side is down. So a positive odd is a down, up. All right, now if I were to make that negative, haha, it's an up, down. Now you can add all sorts of goofy junk to this. All right, but the biggest exponent is an x to the 3rd, and it's a negative. So this is a negative odd. Negative odd is always going to be an up, down. That's just the way it's going to be. Let's think of an even number, an x to the, let's get big. Let's go x to the 8th. What do you know? An x to the 8th is a positive even. Positive even is up, up. So that's an up, up. Now again, you can add and subtract all sorts of goofy junk to this. All right, wow, that's a crazy looking graph, but long story short, The largest exponent in x to the 8th is a positive. Positive even is an up, up. So this left-hand side is going up, this right-hand side is going up. Again, if I were to make this a negative, then it would be a negative even, and that's a down, down. Hooray. You now know about end behavior as far as just looking at the equation is concerned. Okay. Now, if you don't get it, okay, I get it sometimes. Just type it into your Desmos calculator. Oops. And take a look. All right, so I type that first equation, which I know is a positive even. I know that's going to be an up, up, but in case I forgot that, just take a look at your picture. The left-hand side is going up, the right-hand side is going up. That's an up, up. Now, what that means is this. So when x goes to negative infinity as part of your answer, that is in essence describing that is as it's going left. As x goes to positive infinity, that's another way of saying it's going right. So what is the left-hand side doing? Oh, that's going up. And so up is another word for positive infinity. The right-hand side is also going up, so that also would go to positive infinity. If it's going down, it would be negative infinity. All right, so what I see about this first problem is this is a positive even. That means it's an up, up. This next one, I see this is a negative odd. The first number is negative and it's an odd, so it's usually down, up, so this is going to be up, down. So the left-hand side is going to go to positive infinity. The right-hand side is going to go to negative infinity. And again, if you don't know, check it on your Desmos calculator. So we have negative x to the 3rd plus x squared. What do you know? It's an up, down, positive infinity, negative infinity. Hooray! Okay. Identifying the minima. It says use your Desmos calculator. So they just straight up want you to use your calculator. So we begin by typing this into our calculator. All right, and so minima, maxima, let's start with maxima. It's a plural of maximum. That would be, where is there the tops of any bumps? Okay, that's called a maxima or maximum. Okay, minima is plural of minimums. Okay, is looking for any bottoms. So any bottoms that you have, like bottoms of valleys, would be minimums. All right, so here I did graph this particular equation. And this particular equation looks something like this. All right, so I do have some minimums. They would exist right here and right here. How can I get that from my Desmos calculator? Is I'm going to scroll kind of in so I can kind of take a look. And if I click on the graph, it kind of brings up some important points. So if I need to know these minimas, I need to know that and that. So if you just hover your cursor over it, it should tell you what you need to get. So this has a minima at negative, what did it, was negative 7.1 and yeah, negative 7.1 and negative 2.5. Okay, that's what the minimum is, and it says round to 2 decimal places. So let me talk about that real quick. So on my calculator, it said this was negative 0.707, I believe. So if I'm rounding this to 2 decimal places, okay, I see that 7 is a big number, so I have to like add a 1 on there. So that would be 7.1. Okay, so that is that minima right there. Okay, but that's not all of the minimas. There's another one. So that's one of them. The other one occurs at positive 0.71 and negative 0.25. So it occurs at a positive 0.71 and negative 0.25. Those are the two minimas that I have. Okay, next, what I'm looking for is the average rate of change. The average rate of change is the same thing as the slope. The slope is defined by y2 minus y1 over x2 minus x1. That helps you find the slope. It's, in other words, the rise over the run. Okay? All of these things are the exact same thing. So if they're asking for an average rate of change, they want to know what is the slope between the two places that they figured. So if they say identify the average rate of change between the max and the min of the following function. All right, so let's take a look at that following function in our calculator here. So we have x to the third minus 3x squared plus 3. Zoomed in here. All right, so here we go. So they want to know what is the average rate of change, aka what is the slope between the maximum and the minimum. So let me draw a rough picture so I can explain what I'm doing here and thinking about. So right now our picture looks, ooh, that's gross. Try that again. A little bit more steep than that. Something like that. It looks something like that. So the maximum is right here, and the minimum is right here. So let's go ahead and identify those points. So I see that the maximum occurs at 0, 3. The minimum occurs at 2, negative 1. All right, so I can do this a couple different ways. So I know that the average rate of change is the slope. So what is the slope between those two things? Well, I see that if you want to count, you can use your picture, and I can count, and I see that that is a rise of negative 3, a rise of 3 and a run of 2. All right, that's a rise of 3 and a run of positive 2. So I see that has a rise of 3 and a run of 2, and then this is going downhill. This ultimately is going to be negative 3 over 2. But if you get confused by all the lines and all the grid marks that are on the Desmos calculator, I get it. You may want to go with the second strategy, and that is using this equation right here. So that would be y2 minus y1 over x2 minus x1. Oh, I'm sorry. That's a rise of 4, and I'm sorry, that was a rise of 4 and a run of 2. Negative. I'm sorry, this is negative 2. Sorry. Again, even I got confused just trying to count. So I would probably rely on the equation, y2 minus y1 over x2 minus x1. That's the slope. That's the exact same thing as what they say is, what is the rate of change? What is the rate of change? Rate of change is the slope. Identify the minima. Oh, same equation. Minima. Bam. It's at 2, -1. Okay, again, the minima is the bottoms of any valleys, and this one occurs at 2, -1. That is the minima in that situation. Same equation again. What is the maxima? Maxima is the tops of any hills. And so I see that the top occurs at 0, 3. That is the maxima of that equation. Identify any zeros. Again, what a zero is where does the graph cross the x-axis? Not where it crosses the y-axis, but where does it cross the x-axis? Those are zeros. Those are zeros. So let's go ahead and graph this thing. We have x to the 4th minus x squared. All right, so I'm going to zoom in here a little bit, and it looks like we have -1 and +1. So the zeros of this particular picture, oh no, I'm sorry, and there's 1 at 0, 0, I'm sorry. So it touches right there, and right there. There's 3 zeros. Those things happen to occur at -1, 0, 0, 0, and +1, 0. That's where all the zeros occur. Number 8, identify all the zeros. So that would be x to the 3rd minus x squared minus 5x plus 3. Zoomed way in here. All right, so looks like we're in business here. So we have zeros at -2.09, -2.09, 0.57, and 2.51. So let's take these one at a time. So we have that one right there. Keep forgetting the number, and it's hard to work on 2 different screens. -2.09. That's one of the zeros. That middle zero, again, where it crosses the x-axis, is at 0.57. And the third zero occurs at 2.51. Identify the zeros of that. Not a big deal. Ooh, tricky, tricky. Okay, so you'll notice that this is the x-axis. Does this ever touch the x-axis? No, this never, ever, never touches the x-axis. This picture kind of looks something, doesn't look anything like that. Let's try that again. Come on, Ashton, you're better than this. Okay, the picture looks something like that. Notice how it never touches the x-axis. So what are the zeros? None. There aren't any. There's no zeros in that situation. Do not exist. Okay, approximate the graph. Oh, I guess I could have graphed. It's the same equation, so what does this thing, approximately, what does this look like? Oh. Again. There. Oh, that was a good one. It kind of looks like that. Kind of looks like that. Notice how it's down, down. That's a negative even. It is down, down. Great. You may be noticing that I'm typing into Desmos calculator, and I'm not actually using the keypad that they have available, just because I can type with my keyboard a lot quicker. So a question that you may be asking yourself is, how can I, or how do I put in an exponent? Like, say I want to type in negative x to the fourth plus 3x squared, or something like that. Let's say I want to type that into my calculator. All right, so I literally type a minus, okay? I literally type the letter x. Okay, now how do I get this to an exponent of 4? Okay, this exponent of 4. Here's what I type. I first have to hit this button right here, which is right above the 6. So it's like it's shift 6. Okay, it's that button. Okay, it's called caret. Shift 6. Shift 6 puts you up into these exponent type things. So I go shift 6, and then I type whatever I want into my exponent, 4. Okay, now if I don't do anything from here, it's going to keep typing into my exponent. So in case I don't want it to look like this, okay, I don't want my problem to look like that. I need my value to be a regular plus 3x squared kind of idea. So what I need to do is, after I'm done entering my exponent, I literally hit the over arrow, just the over arrow. And what that does is it gets me out of the exponent and then back to typing regular letters. Okay, it gets me to typing regular letters from there on out. So very brutally long, what I would type to enter this is I hit negative x, I go shift 6, okay, 2 button pushes, I guess. It's like a simultaneous. Okay, what it is I'm after is that symbol, that shift 6, 4, over to get me out of that exponent. Then I'm on to the other part, which is plus 3x. Again, shift 6, which is the caret. So again, that would be negative x, caret. So notice that I'm up at 4th, arrow over, plus 3x, caret 2. There it is. That's how I enter that equation. Again, if you totally get lost, that's not a big deal. You can use this keypad if you're used to this. So negative x to the, I think they have to this, is it to this b? Yeah, to this b for, I'm going to arrow over. I don't know how to get out of that. I'm going to arrow over. And then there would be plus 3x to the 2. And again, I'm physically arrowing over, so I get out of this exponent. Otherwise, if you don't arrow out of that, you can sometimes accidentally do something like this. Oops. Didn't mean to write that. X to the 4th plus, creepers, come on, Ashton, here we go. Negative x to the 4th plus, oh, I guess it does drop it down. That's good to know, because what if I wanted it up in the exponent? Learn something new every day. Okay, anyways, I guess you don't have to arrow over.
functions. All right, that's it.